Hi, second year students. It's math with AUB. Let's continue our journey in the field of new book for second year exercise 3.3. I have split this exercise into two parts in order to give you good view, and we remain in a limited frame that we can grasp, grapple, understand, digest. So, without wasting time, let's embark upon our journey. Number one, such type of question we have solved in 3.1. I think yes, we have. That is, if I am not wrong, it is the case. Some sort of some constant here might be 9 or 7. That is the case. That is the case. We have done so. This it is. Ask yourself, what is differentiation of x square? That is 2x. What is differentiation of x square? That is 2x. It is not the case. It is not the case. If there would have been an x or 2x, then we would have done like this. Deficiency of 2x dx, x square plus 9. Function is in the denominator. Function is in the denominator and differentiation in the numerator. Function having overall power 1. That is the situation we have discussed several times. Let's see once more. Derivative function having overall power 1 in the denominator. That is the case of ln. Function whatever the present in denominator. Same situation here. So it can be concluded as ln x square plus 9 plus c. But we don't have x in the numerator. But we don't have x in the numerator. So this is altogether different distance. First of all, we look for function derivative. We look for function derivative. We look for function derivative. If this is not the case, then we think another possibility, that is let me give you general form, that is our integral dx x square plus a square. It is given by 1 over a tan inverse of x over a, or one can write instead of inverse, one can write arc tan x over a plus c. Switching over to that possibility, magic substitution, we have to convert this data into that form. There is a 9, I can write instead of 9 x square, instead of 9 we can write 3 square. What is the magic substitution here? In case of plus sign, x is equal to a tan theta. Compare the situation we have, r constant equal to 3 tan theta. Differentiating with respect to theta, dx over d theta. We are familiar, differentiation of tan is sec square theta. Solving for differential dx, we have 3 sec square theta d theta. Number 2, number 1. Utilize both these values here. Dx, instead of dx, write 3 sec square theta d theta. Instead of x, 3 tan square. So we have something like this: 3 sec square theta d theta x square. We have 3 tan. I can write 3 square as well as tan square plus 3 square. Taking 3 square common from the denominator, I have 3 sec square theta d theta. 3 square common, I have left with tan square theta plus 1. It is identity from trigonometry. Tan square plus 1 or 1 plus tan square, 80 is equal to sec square. 80 is equal to sec square. Cancelling out, we have a single 3. Right outside, 1 over 3. What remains? Sec square theta d theta over tan square plus 1 is equal to sec square theta. Cancelling out, we have 1 over 3, only 1 d theta. 1 d theta. Its differentiation of theta with respect to theta is 1. So integration of 1 with respect to theta is theta plus c. Actually, our variable is x. Now we are roaming wandering in theta. We put the value here. From here, I can manage the value of theta by x is equal to 3 tan theta. Solve for theta. Shift 3 here. It will become x over 3 tan theta. In order to get rid of tan, introducing tan inverse both sides. Tan inverse x over 3 is equal to tan inverse tan theta. They are cancelled out. So theta is equal to tan inverse of x over 3. X over 3, that is the case. So our answer is 1 over 3 theta means tan inverse of x over 3 plus c. That's our answer in that case. It's equal to 1 over 3 tan inverse x over 3 plus c. Its latter matter for MCQ type question. It's 9 can be written as 3 square. We plug in just value of a, that's 3. 1 over 3 tan inverse of x over 3 plus c. That's our answer in that case. It's a lateral stage. Lateral stage. First of all, we grapple the situation, we understand the situation, we grasp the situation tightly, we have a command over the situation, then we are in a position to apply these things direct for MCQs. Moving towards second question, it is also based on magic substitution, but let me split this for you. Is simple function derivative situation as well as situation for magic substitution. In case of positive sign, x square plus a square, we always manage x is equal to a tan theta, magic substitution, x is equal to a tan theta. In case of positive side, if function derivative situation doesn't prevail. Moving towards question number 2. 2, that is dx over 5 minus x square. 5 minus x square. If there would have been x, then we switch over to function derivative situation, substitution as, look at this, 5 minus x square is minus 1 over 2 times x dx. Look, function is not overall 1. If function is overall 1 in case of previous question, then it is case of tan inverse. If function is in the denominator having not power equal to 1, then it can be reproduced into numerator by changing the sign of the exponent and so on. Suppose y is equal to 5 minus x square, differentiating with respect to x, dy over dx, 5 0 minus x square is minus 2x. dy is equal to negative 2 times x dx. Look here, we are only interested in the value of x dx. Shift minus 2 here, it will become dy over minus 2 is equal to x dx. That's our number 2. That's our number 1. Put here, it will become something like y is minus 1 over 2 dy over minus 2. Write minus 1 over 2 outside and simply integrate by adding 1. By adding 1, it will become y is 1 over 2 divided by 1 over 2. 2 to cancel, report the value of y, that is y means 5 minus x square. 5 minus x square, 1 over 2 means 1 over 2 means root, 1 over 2 means square, 1 over 2 means square. If there would have been x, if there would have been x, that is the situation. But we don't have x. We have to take the assistance of magic substitution. Magic substitution is simply based on how to get rid of this radical sign. In that case, let me write a general form for this, that is a square minus x square. It's given by sine inverse of x over a plus c, where x is equal to a sine theta to be utilized as a magic substitution. So does the situation here prevails. Manage this as a square minus x square. 5 is not a perfect square quantity, so I can write root 5 square minus x square. That is our supposition. Instead of a, we have 5, so we suppose x is equal to root 5 sine theta. Differentiating with respect to theta, because there is theta variable we have supposed, dx over d theta, root 5. Differentiation of sine is cos theta. Solving for differential dx, we have root 5 cos theta d theta. That's number 2. That's number 1. Re-put in the original integral. Take the assistance to get rid of a radical sign. Dx means, integral dx means root 5 cos theta d theta overall root 5 square. We have assumed x is equal to 5 under root 5 sine theta, root 5 sine theta. It's root 5 square as x is square and sine square. Taking root 5 square common, we have something like root 5 cos theta d theta overall root 5 square common. What remains 1? Here remains 1, here remains sine square. Square root of root 5 square is only root 5. That is root 5 cos theta d theta. That is our root 5 outside the denominator, outside the square root, outside the square root. Root 5 square is only root 5. 1 minus sine square is equal to cos square. 1 minus sine square is equal to cos square. 1 minus sine square is equal to cos square. Square root of cos square is only cos square and root cancelled out. There we have something root 5 cos theta d theta over root 5 cos theta d theta. Cancelling out 1 d theta. 1 d theta means theta plus c. Theta plus c. Manage the value of theta from here. It is going to be 5 here. Theta is going to be our sine inverse of x root 5. X over root 5. X over root 5. Look, shift 5 here. X over root 5. X over root 5. To get rid of sine, introducing sine inverse both sides. Sine inverse both sides. Eventually, we are left with theta is equal to sine inverse of x over 5. Sine is equal to x. Let me manage this value. Let me check my friend. I can manage here for you the value. We have suppose root 5 sine theta is equal to x. Shift 5 here. So sine theta is equal to x over root 5. To get rid of sine, shift sine here. It will become theta is equal to sine inverse of x over root 5. X over root 5 plus c. X over root 5 plus c. X over root 5 plus c. That I have managed for you. It is 1 over sine inverse x over a. X over a here root a is root 5. A is root 5. That is the case that I have mentioned here as well as proved for you. Going towards next question. Question number 3. It is simply based on function derivative situation. Is prevalent here, is present here. Just easily negotiate this question. Question number 3. 2x plus 7. Other bracket is x square plus 7x plus 3 raised 4 over 5 dx. 4 over 5 dx. It is not simple integration because overall power is 4 over 5. 4 over, it is not simple integration. After simple integration, we have to switch over to function derivative situation. Function derivative situation. As it is a heavier function, bigger function having fraction power causing problem, take this one as your function if possible. If possible. Differentiation of x square is 2x. Good. Differentiation of 7x is 7. Bingo. That's our function. That's our derivative. Arrange the situation. In order to look better, x square plus 7x plus 3 raised 4 over 5 times 2x plus 7 dx. Now that's our function, that's our derivative. One can add directly in 1 into the power of the function. It will become 9 over 5 divided by 9 over 5 plus c. 9 over 5 can be written 1 over 9 over 5 can be written as 5 over 9 times x square plus 7x. Here there is 3. Constant is x square plus 7x plus 3 raised 9 over 5 plus c. That's our answer. That's our answer. Or one can take the orthodox method. Suppose it is equal to y, differentiating with respect to x, find the value of this one and so on. Let me do it for you as well. Proper substitution in order to give you a good view. Y is equal to x square plus 7x plus 3 differentiate with respect to x, dy over dx is equal to x, 7 times 1, differentiation of 3 is 0. Solve for differential y. That's our 2x plus 7 times dx. That's number 2. That's number 1. Suppose substitute here. Let me write this in arranged manner. X square plus 7x plus 3 raised 4 over 5 times 2x plus 7 dx. It's our y raised 4 over 5. That's our only dy. Add 1 into the power of the function as it is simple integration now. It is simple integration. We have only used single term. Add 1 into the power of variable and dividing with the same. It will become, by the way, 9 over 5. 9 over 5 by adding 1. 9 over 5 dividing with the same. It will become 5 over 9. 5 over 9. Reput the value of y. Reput the value of y. It is our x square plus 7x plus 3. That's our answer in that case. That's our answer in that case. Question number 4 is also a simple integration case. X cube having derivative 3x square. There's only deficiency of 3. Let's see and find out this one as well. Question number 4, that is x square dx over x cube plus 1. It is not a simple integration. Something is indivisible. Differentiation of x cube is 3x square. We are good with that. X square is there. Deficiency of only 3 divided multiplied by 3. 1 over 3, it will become 3x square dx divided by x cube plus 1 overall power 1. I am writing for you in words, anyone, even in capital letters, in order to emphasize the situation, underlying situation. Function derivative, that is the case. Different derivative present in the numerator, function is in the denominator, having overall power 1. Having overall power 1. It is the case of ln function, whatever is present in the denominator. Same is here, 1 over 3 ln function present in the denominator. That's our answer in that case. That's our answer in that case. Or one can take it's equal to y and manage the situation. Okay, I have done this one little bit direct. I have given you so many times this idea. Now it is almost your second nature. You utilize this one at once after witnessing this wherever it is present. Okay, question number 5. Question number 6. Question number 5. dy over y square plus 8y plus 20. Look, differentiation of y square is 2y, 8y is 8. That is not the case. That is not the case. Look at this one. We can manage this one into either partial fraction or the magic supposition for 10. How? By making this one as perfect square quantity. Perfect square quantity. Let me manage this here for you first, then there. Y square plus 8y plus 20. It's good. It's a perfect square quantity. Here must be twice first into second. First into second, there is a 2 times y times 4. So second term is R4. Second term is R4. So there must be 4 square. There must be 4 square. That is the situation. 2 terms are present. Instead of 16, we have 20. We can manage the show for 16. dy over y square plus 2 times y times 4. 2 for the 8y, it is present here. There must be y square. There must be y square. There must be y square. So add and subtract y 4 square. Add and subtract must be a square plus 2ab plus b square. Whatever is the original constant, keep it. Now it is the perfect square quantity. It is y plus 4 whole square. dy over, take the first one and the third one without square, taking the symbol of the middle one. It's y plus 4 overall square. One can read this situation again. Y square twice, first into second plus square of second. We have left with minus 4 square means 16 plus 20. Minus square belongs to only 4, not to minus. Square only belongs to 4, not to minus. That's why I have kept a minus symbol. Minus 16 plus 20. What is the situation there? dy, we have y plus 4 whole square plus 4. Plus 4. Okay. Instead of 4, I can write dy y plus 4 whole square. Instead of 4, I can write 2 square. I can write 2 square. I can write 2 square. Same situation is present here. Like that is the major symbol. That's our single variable x square plus a square. X square plus a square situation. That's our x, that's our a. Suppose x is equal to a tan theta. Owing to this positive sign. Owing to this positive sign. X is equal to a tan theta. Instead of x we have our variable is y plus 4 and our constant is 2 tan theta. Manage the shoe. That's our variable. Instead of x we have y plus 4. Suppose y plus 4 is equal to, instead of a we have 2 tan theta. Differentiate with respect to theta, dy over d theta. Differentiation of 4 0 and differentiation of tan is sec squared theta. Solve for differential y. We have dy is equal to sec squared theta d theta. That's our number 2. That's my number 1. Put here, put here, put here. Let me check my space as usual. I'm cautious to write something in a perfect manner to give you good view. How I can manage this? Let's see and find out. Let's see and find out. Let me use these 2 steps. Okay. We have arrived here. That is, okay, let me write this step again. That is dy y plus 4 whole square plus 2 square. Okay, cool. We have assumed that y plus 4 is equal to 2 tan theta. Instead of this, write 2 tan theta. And instead of dy, write 2 sec square theta. So we are having 2 sec square theta d theta. Instead of y plus 4, 2 square tan square theta plus 2 square theta. Taking 2 square common from the denominator, we have something 2 square common, we are left with tan square plus 1. Simplifying, we have 1 over 2 situation, sec square theta d theta. 1 tan square plus 1 is also equal to sec square theta. Same situation again, it's r 1 over 2, 1 times d theta. 1 over 2, 1 times d theta. 1 times d theta. So integration of 1 is theta with respect to theta. Manage the value of theta from here. Shift 2 here, it will become y plus 4 over 2. I have something like tan inverse of y plus 4 over 2 plus c r1 can write 1 plus r 10 something like this. How? Just check. I have y plus 4, there is 2, there is tan theta. Solve for theta in that case, solve for theta. Shift 2 here, it will become y plus 4 over 2. We are left with tan theta. In order to get rid of tan, introduce tan inverse both sides. Tan inverse y plus 4 over 2. We have tan inverse tan times theta. They are neutral. We have, so we are left with tan inverse y plus 4 over 2 is the value of theta. Is the value of theta. That I have managed for you here. That I have managed for you here. Okay, cool. Moving towards final question. Moving towards final question. We have something like, okay, let me manage this space properly. Dx over root 20 minus x square minus 4x. Look, it is not the case of function and differentiation. Just make this one a perfect square quantity. Then it will take the shape of either magic substitution for sine, tan or sec. Sine, tan or sec. Let's see and find out. That's the case for tan. That is the case for tan. X is equal to a tan theta. And this one, x is equal to a sine theta. And if that is the case, variable for then constant, it's the case of x is equal to a sec theta. Some writers assume x is equal to a cos theta in that case as well. for 10, whether it is in root or not in root. In both situations we suppose 10. If there is no square root, then they are naturally or most probably the case of partial fractions. These are the cases of without square, partial fractions, partial fraction. All these things are coming up advantages. So make it perfect square. It's really cool and easy. 20, taking minus common, x square plus 4x. If I have taken x common, then it is no more a perfect square shape. Okay, transforming this into perfect square, 20 same, it is our x square. Instead of 4, one can write twice. Here is x and there is 4. I can write 2. 2x times 2, it will become same 4x. It will become same 4x. So I have good idea. The other term is 2. Other term is 2. A square 2ab plus b square. We have to add as well as subtract this term in order to make it perfect square. That's our perfect square quantity of x plus 2 whole square. X plus 2 whole square. How to shrink this? Take first one, third one without square. Take the symbol of the middle one. Dx over 20 minus its the concise form is x plus 2 whole square. Here is minus 2 square is equal to 4. Let me repeat again. Square belongs to 2, not to minus. Square belongs to 2, not to minus. Just multiply this minus. We have dx over 20 minus x plus 2 whole square minus minus plus 4. 20 plus 4, how much? 20 plus 4, how much? That's our 24. That's our 24. We have x plus 2 whole square. 24x plus 2 whole square. So arrange this one into perfect square quantity. 24 is not a perfect square quantity. Even then we can manage the square. Instead of 24 I can write 2 times root 6 whole square. The square of 2 is 4 and the square of root 6 is only 6. 4 6 are 24. Same minus x plus 2 whole square. X plus 2 whole square. Now that's our case a square minus x square. A square minus case x square. That is the case of sine because under root is also present. Under root is also present. Suppose in that case, suppose x is equal, instead of x is equal a sine theta. If we compare this with our situation, we have instead of x, x plus 2 and instead of a we have 2 times root 6. 2 times root 6. Differentiate with respect to theta, dx over d theta. Differentiation of constant is 0. 2 times 6. Differentiation of sine is cos. Solve for differential dx. We have 2 times root 6 times cos theta d theta. That's number 2. That's number 1. Put here. Put here. Let me check the frame. Okay. Why not? Here, put the values. Dx means 2 times root 6 cos theta. 2 times root 6 cos theta d theta. Overall, 2 times root 6 square minus, instead of this x plus 2, we have assumed that x plus 2 is equal to 2 times root 6 sin theta. Means 2 times root 6 square and sine square. Taking 2 times 6, 2 times root 6 square common, we are left with 1 minus sine square. 1 minus sine square is equal to cos square. Square root of cos square is only cos, cancelled out, and we are done with that. 2 times root 6 cos theta d theta. Taking 2 times root 6 square common from the square root, we are left with 1 minus sine square theta. 1 minus sine square is equal to cos square. Square root of 2 root 6 square is only 2 root 6. 2 times root 6 cos theta d theta. It's our 2 root 6 outside the under root. We are left with 1 minus sine square. 1 minus sine square is equal to cos square. They are cancelled square. Cos square means only cos. Cos square means only cos theta over cos theta d theta. We are left with 1 d theta. 1 d theta means only theta plus c. Theta plus c. Arrange the value of sine from here. It will become sine inverse of x plus 2 over 6. X plus 2 over 6. So theta plus c, it is tantamount to sine inverse of x plus 2 over 2 plus root 6 plus c. It's our final answer. It's our final answer in that case. It's our final answer in that case. Let me check the steps. Everything is visible and clear. We are good with that. We are good with that. So these are the three cases to be utilized as magic substitutions for plus 10. Constant first, variable later, middle symbol is minus, and there is a power of type 1 over 2, 3 over 2 square, whatever the case is. We assume x is equal to a sin theta or x is equal to a cos theta. If prior to constant is variable, then constant middle symbol is minus, power is same 1 over 2, 3 over 2 r square. We switch over to x is equal to a sec theta, provided that if the function and derivative situation fails, means direct substitution fails, then we move towards these suppositions. That's my tiny effort for you guys for exercise 3.3. I will give you clear idea about these cases in tomorrow's frame, because questions are very limited. The remaining from 7 to 12, they are very light questions, I focus on these suppositions for you in detail, from where they comes or occurs, how to manage them or how to utilize them direct. It's my tiny effort for you guys. It's all by itself. Next.